Welcome to session 11 of RDBMS and data management. One of the most important database objects in SQL Server are tables. Tables in SQL Server contain columns, each of which may have data of a specific type and class. This session explores the various data types provided by SQL Server and how to use them. Creation, modification, and removal of tables are also discussed. This session introduces the new XML data type and describes how to work with XML data in SQL Server tables. A brief look at XQuery language, which is used to query XML data, is also discussed in the session. So, our session objectives are define the data types and list the categories in SQL Server, describe how to create, modify, and drop tables in a SQL Server database, describe how to add, modify, and drop columns and constraints in a table, describe how to work with typed and untyped XML, explain how to create, use, and view XML schemas, explain how to use XQuery to access XML data. We come to data types. A data type is an attribute that specifies the type of data an object can hold and its storage capacity, such as a numeric data, character data, monetary data, and so on. Once a column has been defined to store a particular data type, data of another type cannot be used to store in it. In this manner, data types enforce data integrity. Consider a column named basic salary in a table employee to ensure that only numeric data is entered. This column is defined to belong to an integer data type so that even if an attempt is made to enter character data into that column, it will not succeed. We come to data types in SQL Server. Various items in SQL Server, such as columns, variables, and expressions, are assigned data types. SQL Server supports three kinds of data types. They are system defined data types. These are provided by SQL Server. Alliance data types. These are based on the system supplied data types. One of the typical uses of alliance data types is when more than one table stores the same type of data in a column and has similar characteristics such as length, nullability, and type. In such cases, an alliance data type can be created that can be used commonly by all these tables. And the third are user defined types. These are created using programming languages supported by .NET framework. We come to the commonly used system defined data types of SQL Server. First category is exact numerics, in which we have data types as int. A column of this type occupies 4 bytes of memory space. It is typically used to hold integer values. The next is small int. A column of this type occupies 2 bytes of memory space, can hold the integer data from minus 32768 to positive 32767. The next is tiny int. A column of this type occupies 1 byte of memory space, can hold integer data from 0 to 255. Big int. A column of this type occupies 8 bytes of memory space and can hold data in the given range of minus 2 exponential 63 to minus 2 exponential 63 minus 1. Coming to numeric. A column of this type has fixed precisions and scale. Money. A column of this type occupies 8 bytes of memory space, represents monetary data values which ranges in the given range from negative to positive. Moving ahead, we come to the next category, that is approximate numerics, in which we have data types as float. A column of this type occupies 8 bytes of memory space, represents a floating point number that is ranging in the given negative through positive range. The next is real data type. Column of this type occupies 4 bytes of memory space, represents floating precision ranging from negative through positive numbers. The next category comes as date and time, in which we have data type as date time, represents date and time stored as two 4-byte integers. The next is small date time, represents date and time. Moving on to the next category, that is character strings, wherein we have data types as char, stores character data that is fixed length and non-Unicode. Varchar stores character data that is variable length and non-Unicode. The next is text data type, which stores character data that is variable length and non-Unicode. The next category is Unicode types, wherein we have nchar, which stores Unicode character data of fixed length. We have nvarchar that stores variable length Unicode character data. Moving on with the next category, that is other data types, in which we have the first as timespan. A column of this type occupies 8 bytes of memory space, can hold automatically generated unique binary numbers that are generated for a database. The next is binary n, stores fixed length binary data with a maximum length of 8000 bytes. The next is var binary n, stores variable length binary data with a maximum length of 8000 bytes. The next is image data type, stores variable length binary data with a maximum length of 1073741,823 bytes. And the last comes unique identifier. A column of this type occupies 16 bytes of memory space, also stores a globally unique identifier, that is GUID. We come to alliance data types. Alliance data types can be created using the create type statement. The syntax for create type statement is we say create type schema name dot type name from base type precision comma scale constraints either null or not null, where schema name identifies the name of the schema in which the alliance data type is being created. Type name identifies the name of the alliance type being created. Base underscore type identifies the name of the system defined data type based on which the alliance data type is being created. Precision and scale specifies the precision and scale for numeric data. Null or not null specifies whether the data type can hold a null value or not. Example, we say create type user type from where char20 not null. If we use this, we create it using SQL query, and when we press F5 or execute the statement, it gives us the message as commands completed successfully.